So let's do some practice Lewis structures. Let's start with ammonia. We need to figure out which atom is going to be in the center. Well, we know that the hydrogen can only make one bond. Since it can only make one bond, it has to be on the outside. So the nitrogen will have to be in the center. So our molecule will have to look like this. And we'll have to have bonds between the hydrogen, so I'm drawing lines. Okay, we need to figure out how many electrons we're dealing with. Nitrogen is on the periodic table in the 5A column, so it has 5 electrons. The nitrogen is in the 1A column, so it has 1 valence electron, but there are 3 of them. So I have 3 hydrogens, each with 1 electron. That gives me 8 electrons to place. Now, I've already placed 6, 2, 4, 6, 7, 8. That's the Lewis structure for ammonia. So let's do water. H2O. Again, the oxygen's going to have to go in the middle because the hydrogens can't be in the middle. So we'll have to put the oxygen there, and it'll have to be attached to 2 hydrogens. We've got all our atoms, and they're connected by bonds. Let's count up how many valence electrons we have. Oxygen is in the 6A column, so it has 6 valence electrons. We have 2 hydrogens. Each has 1 valence electron. That gives us 8 electrons to place. We've placed 2, 4, 6, 7, 8. Note, I did not put these extra electrons on the hydrogens because they only need 2. Let's count and make sure everybody's got an octet. The hydrogen doesn't have an octet, but it has 2 electrons, and that's all it wants. The oxygen has 1, 2, 3, 4, 5, 6, 7, 8. So it has an octet. Everybody's happy. So let's look at something that's a little more complicated. Let's look at carbon dioxide. Okay? Let's put the carbon in the middle, and we're going to put the oxygens on the outside. Partly I did that because there's only 1 carbon and 2 oxygens. The one that's by itself I put in the middle. Carbon is on the 4A column, so it has 4 valence electrons. And then we have 2 oxygens, and we said each oxygen has 6 valence electrons. So that's 12, 13, 14, 16. 16 electrons to place. Okay, we've already placed 2, 4, and so I'm just going to start putting electrons. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now I'm out of electrons. I don't have any more to place. And it looks like the oxygens are in good shape. They all have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. But the carbon, it only has the 2 bonds, so it's only got 4 electrons. It's not happy at all. This is the case where we have run out of electrons, and we'll need to do double bonds. So let's erase these 2 and put them as shared. Erase these 2 and put them as shared. Now, carbon has 4 bonds. 1, 2, 3, 4, and that gives it 8 electrons. So the carbon is happy, and the oxygens have the 2, 4, 6, 8. So they're happy as well. Let's look at a polyatomic ion. Let's get nitrogen, nitrate. That's nitrate. So we're going to put the nitrogen in the middle, and we're going to put oxygens on the outside. So let's count up our valence electrons. We've got a nitrogen that's going to have 5, and we've got 3 oxygens which each have 6. Then we have something new. We've got this charge, that's another electron, so let's add that electron. Okay, so we've got 16 plus 6, and that gives us 24 electrons. It's a lot of electrons. So let's just start putting them. We've got 2, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, that looks good. The oxygens look all happy. Each one has 8 electrons. They have 1, 2, 3, 4, 5, 6, and then that shared one that gives them 8. The nitrogen, however, only has 3 bonds, and so it only has 6 electrons. It doesn't have an octet. It's not happy. So let's take, and we could have done this, we can do this with any of the oxygens, but I'm going to pick this one down here. Take those electrons off and make them shared electrons. Now nitrogen has 4 bonds, giving it 8 electrons, and this oxygen down here, it has the 4 shared electrons up here, and then the 2 lone pairs, it also has 8.